Hello, everybody. Let me grab my camera here. Hello. Oh, let me adjust my lighting real quick. Give me a second. My lighting keeps reversing itself. Stop that. Stay. Stay just like that. I don't want you to reverse yourself again. That is how you should be, and that is how you should stay lighting. Oh, no, don't do that. Hold on. Stop it. Stop doing things. No. Stop. My be. Yes, there we go. That's the way that you should be lighting. Come on. Come on. Okay. Okay. That should fix its lighting. Lighting should be better now. Goodness gracious, just doing what it wants. Goodness. Okay. Welcome back. So, might be wondering what I mean by getting started on a little T. What happened to the mechanical hand? Kobe. I thought you were doing mechanical hand stuff. What happened to the mechanical hand? Um, well, it's really simple. You see, the mechanical hand needs parts. Parts that I do not have. And as such, gonna have a bit of a pause on that while waiting for parts to ship in, waiting for me to be able to purchase parts, all that stuff. So we're gonna have to pause on the mechanical hand for a bit. We will get back to it. It's just I don't have the supplies to be able to continue working on it. I need to get motors, motor controllers. I need to get crimpers so that I can actually secure the wire the way it should be. All the stuff that I have to get before I can continue on. We need the bearings. We're not going to be doing anything with it if we don't have those bearings in order to make it be able to turn and swivel. So all this stuff needs to be obtained before we can continue with our mechanical hand. So instead, we're going to make his life annoying. Yeah, I'm unsure if you guys are aware, but recently, Smev has been working on a bit of a project. I'm not going to go too much into it, but, well, I mean, obviously, you know, some of it, he's streamed some of it, doing his whole, like, D&D and Minecraft thing, which is really cool. But he made a mistake. I was inviting me to be in it, and saying that it was okay for me to be a Warforged. Basically, the robot. So, not only did he say that I could be a Warforged, I was also told that I'd be allowed to make additions and changes to my Warforged and, like, explain how it works, how the change would work. I'm not going to go too much more into what exactly was said, but I put this down here in the corner. And also, the stream has started. We don't need that. No. Here we go. Like, here's my sheet, right? Got Warforged, Metallic. Basically, we're going to take this Warforged. Oh, and we are going to turn it into an actual robot design. And, in CAD. And every time Smev lets us make a change to it, we're gonna go into CAD and explain how this change works. Boy, I'm gonna have a lot of fun. Smev, maybe not so much, but I'm really gonna enjoy myself. Um, so, you might wonder, okay, that's cool and all, how are we gonna do this? Well, basically, I was in first for like 5 years. I participated in first robotics competition, then before that I was in first Lego League for a couple years. So this is going to be made kind of in the style of a first bot. That being said, we aren't going to have weight constraints and size constraints because I don't like those. So think of this as a first bot, but we get the freedom to experiment around a little bit. First things first, before we even touch any of this, the first thing you want to do when trying to make a robot of some sort, figure out what you want it to do. Anytime you're trying to make something, you need to have a goal, guidelines in place so that you know what you're trying to make. If you don't have any of that, you probably are going to end up in the gutter while you're making stuff because you're like, oh, what was I wanting to do again? I don't know. If you don't have a set of goals in place for what you're trying to make, it won't happen. So for an example, right? Let me see here. For example, let's actually look at first, right? I'm gonna go to a first robotics competition. Let me grab a video of one of their years. First robotics competition, game video. I'm gonna grab let's do, I don't know. This one works. Okay, hold on a second. I gotta add. Gotta wait for the ad to go past. And I need to put this in here, don't I? Okay, let me go ahead and we don't need to actually. It's fine. We don't need the sound. So right, this would be like a game release video that first would make, right? And this would let the teams know what the goals were. This is Rapid React, so you have teams on either side. And then this is talking about the beginning of the game. You could score points inside of this thing and you could climb, right? Just general idea of different things things you could do in the game to do things. So at the start of the game, you have 3 bots on either side, starts on either side. And then they start loaded with a game. They can start loaded with a game piece. And during the first 15 seconds of gameplay, robots are doing stuff on their own. They can score game pieces in there. They get 2 points per game piece, right? After that first 15 seconds, we have human players and things to take on. They can score points again in different areas. I'm not talking about ranking points. All the point systems and stuff, not too important to what we're looking at. Basically, you can see a whole bunch of different things that the robots had to be able to do. And one of the first things that you do is you figure out what you want your robot to do, what you want your goal to be. So, in this game, for instance, you might say, oh, I need to be able to shoot inside of this top hopper here. I need to be able to get in there because that's going to be more points. So we need to be able to shoot. We also need to be able to pick up cargo. We aren't going to worry about it from the ground. We're going to pick it up from over here. So we're going to pick it up from over here. It'll load up and then we'll shoot from there. And you might say, oh, I want to be able to make it to the 3rd rung. That's a couple of things that you might decide on. And then you would try to design around those goals. That's an idea of what we're about to do. That should give you an idea of how we need to come up with goals and things for the for this robot. So then, let me go ahead and pull that up. Okay. First things first, we need to come up with a set of goals. Now, this is a robot. This is a fictitious robot that we are not making in real life. This is all just for the D&D thing. So, first off, when it comes to programming, it'll work slightly differently. As in, it won't be programming, it'll be working off of, magical coding or whatever, blah, 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 blah. We're gonna have a box that we just kind of put over somewhere. We'll make a constraint for a box, and then we just have to make sure that that's in it. So one thing it has to have is the magic programming computer, which honestly is also kind of true in real life. If you're going to make a robot, it does need that computer that has all the magic programming that actually makes it run. One thing that Infirst bots have that we don't have to worry about is a radio. And the reason I say that we don't have to worry about it is because, quite simply, nobody else is controlling our bot. So we don't need any type of radio for somebody else to come in and control what the bot is doing. It's just not a thing that we have to worry about. It'll be fine. We are all good. We don't need to worry about that. Why? You should be randomized music. You just... Yeah, there you go. Randomized. That's what you want. Okay, cool. So that's something that we don't have to worry about. We don't have to design around. We need to be able to drive. We need to be able to move, maneuver, all that stuff we need. We're gonna need armor of some sort in order to protect our inner components. One thing I did talk about with Smev is the fact that I'm gonna have 4 arms. So we need 2 main arms, 2 secondary arms. And that'll be for all of the stuff that we carry and things like that. There's a lot of things that are like tools that we won't necessarily, and bags and things that we won't necessarily need on the bot itself, because that's extra stuff that we just carry. However, we will need a way to get over, and I'm going to put this underneath the drive, because this is stuff about the drive system I'm talking now. So we will need ways to get over obstacles, right? We'll need, if we were to say fall over on our side, we need a way to right ourselves. We need our power source. We need a distribution for that power source. We're going to need cameras and sensors so that we know what's going on. That's separate from power source. We need... We'll get to that in a second, because I need to check with Smev first before I actually type that out. I'm not sure if that'll be secret stuff that Smev doesn't want to talk about. Or doesn't want me to talk about. These are just basics of the robot thus far, right? If we go ahead and look at our sheet, we are going to be an artificer, so we do need something that can detach. That's because I'm going to go with artillerist when I get to that, so I need a detachable module for the cannon. Um, we need a while we don't need a radio, we do need ways to communicate. So that's gonna be via LED signboard and speakers. And we're also going to need, as far as sensors go, I'm just going to make this sensors generally. And we have cameras. And then we also have we're going to need like a microphone. That's it. So as you can see here, we kind of have a list of things that we'll need, right? And there's a lot of stuff that's not on the list because there's stuff that's going to be added during the actual during the campaign. Stuff that I'm not aware of yet. This will just give us the start. So of course, first thing we're going to do, we're going to start with this up here, the drive system. That gives you the basis of how everything else that you're going to add to it. If you don't have a drive system, your robot's not going to go anywhere. So that is what we shall begin with. Now, in order to do this, what we're going to do, let's go ahead and split this up into a couple different areas. We're going to make a new folder. We're going to call this drive. And we need a part studio. There we go. Inside of drive. I'm not going to name this, I'm going to name this the base plate. So first things first, how big do we want the robot to be? How wide? And I think personally that we're just gonna start with like a 3 foot, yeah, like a yard. No, not a yard. We'll start by a 2x2. I think we'll start with a 2x2 square, basically. We're just gonna go ahead and make a sketch here. Let's go ahead and show the origin actually. So delete that sketch, make a new sketch, show the origin, and we're gonna do this a center point rectangle. Let's try and keep everything aligned. This is 2 feet by 2 feet. And then that there links to that. There we go. Now that is in place and that's not going anywhere. Perfect. And the square base is, we can change that. But for now, we'll just start with that. And we'll see how it goes. So this tells us basically, right, this is our area to work with, kind of. And what we're going to go ahead and do now is we're going to look at it from the side and start just putting in some side beams to support the base panel, the base plate panel. Yes, that sketch is fine. And this is something that I did not do with the mechanical hand, but is good to do. That is to list out what is going on. So, for instance, this first sketch is the base plate sketch. At least it will be if I can spell it. Make a new sketch. This sketch will be base plate side beam sketch. And so there we go. The front plane, and then we'll go ahead and we'll put in, we don't want that. We want corner rectangles. There we go. We're going to go ahead and use this point from our other sketch. And we will make it a... We're going to go ahead and... Because I do still want it to be theoretically something you could make in real life. So we're going to say yes to that. And we're going to go ahead and head over to McMasterCard. And from here, we're going to go to hardware, I believe it'll be. Let's go ahead and go down some. Basically just looking for the square pipes. I think it'll be in, no, not raw metal, raw material. Can't remember what it's called. And we're doing this in order to get the measurements so that we can just go ahead and make it real quick. Would this be it? No, that would not be it. I can't remember the names. I can't remember names and things. Names and stuff is hard, guys. Probably is extrusions, right? We really don't want any of that. What is it? What are they called? Like square piping, but I can't remember what it's called. Oh, I can just, oh yeah, that makes sense. Okay. That makes sense that I could just like look up that. That makes a lot of sense, actually. I'm an, okay. Slight idiot, yes. Wow, look at that. There it is. Oh, it is raw material. Oh, I didn't think that it would be there. Okay. Okay, well that's fair, I guess. We do want it to be strong, so we're just gonna go ahead and go with steel. And here we go, thicknesses. Here we go. So here are the thicknesses that we could choose from. We're gonna go ahead and go with, I guess, okay, that's good. So inside, outside, okay. This will tell us the difference, so we'll go with the inside and then basically just need to make two different things. And this tells us the thickness of the wall, right? We're gonna go with this one right here. That's fine. So, looks like 1 inch is the thickest it can be, just a 1 by 1. Which is fine. This one here, is this? Oh, this one we can do 2 by 2. Okay. Or up to 6 by 6. I think we'll go with 2. Is it all square? Yes, it looks like it. Yeah, it looks like they're all square. That's fine. I think we'll go with low carbon. No, we want high strength parts. So yeah, we'll go by, we do have 1 by 2 here. We could do 1 by 2. I think we'll go ahead and do that. So we'll go back over here to our side beam sketch. Grab you. Two inches by I've never seen that button before. Huh. Getting distracted. Okay. 1 by 2. That is the outside, I believe. We then look at here, we can look at 0.065 inches. So we can just go ahead and do an offset of 0.065 inches. There we go. And that is a tube. And so then we can just go ahead and extrude this and we'll have our tube. And the nice thing is that if we just look at this from like the top or something, I think we should be able to extrude it out to that length. Now, in order to secure the tubes together, we're going to go ahead and first off, let's go ahead and make the up to vertex go to U, and then second end position. Up to vertex go to U. Very nice. How do I want to secure these? There's a couple options we could do to secure them, right? We could bring one of these sides out by another inch and then put a bolt through that into the next one and just do that for each one. We could also have 2 longer ones that we just put bolts through for the longer ones. Either one of those is an option. I think we'll go ahead and make all of them the same size. Just bring it out another inch and then put a bolt through. I think that'll be fine. So we're gonna go ahead and name this side beam extrusion. And let me see if I can go ahead and just offset distance is not it. Up to this vertex. Maybe it is. Yeah, there we go. And then offset of 1 inch. Perfect. So that is our tube. So what we can do now is we can just copy this tube and paste it around the sides. So if we were to just take this part, we go ahead and copy it in place once. Again. And again. Very good. Or actually, no, we're not going to do that. We're not going to do that, actually. I completely forgot. I can just translate it first. And then once it's translated, I can just then copy it in place. So we're going to take it from this mate connector. If we do it, let me think here. I think that's the outer wall, so that outer wall would be this inner wall. That was not what I was looking for. What mate connector did it connect to? This mate connector. That mate connector to this mate connector. No, because we're doing it front on, so it's going to need to be a side of it, isn't it? Like that. Yeah, that's it. Then we can flip this around. Flip the primary axis. Like so. I think instead of this mate connector, we'll put it to this one. And then we can flip it. There we go, just like so. And just like that, we have our first one in place. And this is going to be can I stop forgetting parts? There we go. Good. And then we just repeat that for these other two. So that if that's the back, this will be the front, looking at it head on. This will be the right, so this will be side beam left. We're not copying in place, we are translating by that and doing a copy part. So let me see if I remember right. It was this one to this one. And then we flip this. Maybe not. Maybe we flip that. And then flip it up. Perfect. And this one will be side beam front. Like so. Transform by mate connectors. A copy of the part from back here. This one all the way over to that one. Where's my part gone? Why are you all the way over there? What? Oh, it's the wrong part. That's why. That's why you're all the way over there. Okay. That makes a lot more sense. Okay. And okay, there we go. We have all of those now. All of that is in place. Go ahead and rename these. Side beam right. Side beam back. Side beam left. Side beam front. Very good, very good. Okay. Go ahead and get rid of these. We don't need them. That gives us all of our different side beams. Very good. This base plate sketch we're going to go ahead and go back to, and we're going to make some changes here. We're going to go ahead and bring the base plate out by 3/4 of an inch. And the reason for that is that now we can add in some holes, which will allow us to actually be able to... Well, what am I trying to say? Brain, come on. We're gonna bring it out that much, then we're gonna bring out a separate one that's only gonna come out 1/2 inch. That'll be where we actually add the holes to. And the purpose for all of this is so that we can actually have holes to put the base plate onto our beam. So we will go ahead and go to the base plate sketch. We're going to go with a linear pattern. We'll put the holes 1.5 inches apart. And on this side, repeat it. That's going out like how many? We have 2 foot plus an inch on either side, but it's 1/2 inch, so it's only +1. So we have 2 feet 1 inch, right? It's going to be like 3 inch for 1.5 inch holes. That's going to be 25 inches. 1.5 inch holes each would be 3, 6, 9. 16. That's not gonna even out. What are you making? What even are you doing? You should be... What are you copying? I said to make 16 of those, but I'm not sure what the 16 that you're making are. You're making 16... I want you to make 16 points. You know what? It is fine. We just put a circle here. Well, I don't want to put a circle because I'm going to use the hole tool later. That'll mess up that. We put a point, and that's what it's copying. Yes, there we go. That's what we're looking for. Yeah, it's not really lining up now, is it? If we make it 1 inch, does it can it line up that way if it's 1 inch? Man, that's a lot closer though. I guess it's fine. I guess that's fine. Probably need like more though. There we go. 26 that way. 26 this way. Oh, it's gonna make all these points, isn't it? I don't know that I want all these points. I don't want all these middle points, really. I just want lines along that, so, yeah, that's good. So yeah, that's all those points. Do the same thing, but going down. Is it having me edit that one? No, it's not. Okay. This is 1. This one is 26. And then over here, we'll go ahead and add in 2 more. I need to add in a point first. Okay, good. 26. And then same thing, but going up. Up 1. There we go. Yeah, I can't do it negative, but we can do this one to be... Pardon me, where'd all these points come from? Hold on a second. Now hold on just 1 second. There we go. That's what... Yeah, you stay like that. Good. Yes, here we go. New one. That's what we're looking for. And then there we go. We got all our points. We can easily add in holes now. All right. So first things, we're going to go ahead and extrude our base plate. We're going to make it... we want to reverse it. And a depth of... I'm going to say 1/8 of an inch base plate. Very good. And then now what we can go ahead and do is that we got all these holes here, we can go ahead and decide where we want to put the holes in order to hold it in place. Or we won't do that. Because at the moment we've got a big metal plate. This is the base plate extrusion. Right now we've got a big metal plate. That's it. Not even. It's not really holding itself together yet. But that is what we have here. we can't move. So we actually need to be able to move this around and be able to move around on this. We could add wheels and stuff like that. What I want to try to do is add, you can think of them as pistons that can push up and down here, but they're attached to rods. It's rods that come in and out, and on the end is wheels or treads, either one. And that way, if we push down on it, we can lift up the base plate and the rest of the robot, allowing us to try to traverse over objects and obstacles. If you remember, over here, we need a way to get over obstacles. And that's what I'm thinking. And I think that that could be fun. A fun thing to try to design. And it's something that I pitched like every year to my robotics team that I was on. And every year they rejected it. So I'm going to do it now. No, it makes sense why they would reject it. We didn't have enough time to make something like that. I mean, that would be a system that lifts up the entire robot. We just didn't have time to do that. But right now, I'm here at home. I'm not employed. I have time to do stuff. So I'm gonna try to do that. So first things first, what we're gonna do, we're gonna kind of section off some space for it. And in order to do that, we're gonna go ahead and just we're gonna take this very simple base plate. We're gonna make a new assembly. Gonna just call it the drive assembly. And in this new assembly, we'll go ahead and insert our base plate. You can go ahead and boom. Stay so that you don't move. The rest of you are gonna have to get fastened together too, aren't you? Yes, yes you are. Of course you are. Okay, that's fine. It's all good. It's all fine. It's perfectly fine. I mean, I have to fasten you together eventually anyway, so sure, whatever. Let's see here. What's going to this? Okay. We actually don't want to use that connector. We want to use this connector. And then do you to there. And then you is going to be the outside of this next one. So you can go to here. And finally, last but not least, you can go right here. Perfect. Good, good, good. We're gonna go in and quickly make a couple of holes in the base plate assembly over here. We're just gonna find the middle holes here. Yeah, we'll just grab you and you, and we'll just do that on every side over here. We do not need you. You and you. You and you. You and you. Hole tool. We're gonna make you go through all the... Yes, all the way. We're gonna make you go all the way through. And actually, you need to go through 2 points, don't you? Merge scope. This as well. Part 5, which I have not named yet. And which we will name in a second. Start from part. Start from selected plane. Here we go. That is where you'll start. Very good. Termination. I want you to go through this entity. Very good. That is where you'll go, and then we'll make it a 1/4-inch bolt. That's 1/2 inch. We'll see if we'll make it a 1/4 inch. That might be too big. I don't think it'll be too big. I think that should be fine, actually, if it's 1/4 inch. Ooh. Yeah, I don't like that. 3/8 it is. No, not 3/8, sorry. I meant 3/16. Yeah, that's fine. I'm fine with that. That works great for me. I am good. I do not want that. Okay. Alright, base plate. Alright. And why did we do that? Well, it's quite simple. Over here in Drive Assembly, we now have holes to paste things to. That's why we did that. You can go to you right there. Very nice. Now you might wonder, why do all of this? Why make this drive assembly? Why worry about making this now? Because what we're gonna do, we're gonna go ahead and make a part studio in the context. Or create a new part studio based off of the context. If I can remember what that... Here it is. The origin that we'll use, we'll just use this. We'll just use the origin. And because we did this, we can now see. There it is. There's the thing. We can see our assembly. We can make it easier to see and harder to see. Let's go. And the reason for this is that now we can also use stuff in this assembly when we're designing our parts. There we go. Let me get rid of all this. That's going to be really helpful because first things first that we have to do with what we're about to do is we need to add in something here to give us an idea of... we're just going to go ahead and name this planning. We need to add in something so we know how much space we'll need. And I will say, I don't like making these types of assemblies and stuff. But it does make it easy for early on planning. This entire document here will probably be gotten rid of, because the issue with doing things like this is that it works until you change something in the assembly, and then this entire document breaks. Everything breaks. It's just really bad. We don't like that. We don't want that. So, I don't really like doing stuff like this. But once again, what we're about to do, and it's very simple, and you'll understand why we did it this way. First things we're going to do, we're just going to make a sketch. Going to borrow that. And then we're going to borrow all of these. Like so. So now we have each corner. And what we can do now is we can just take this and we can make a couple squares. And you might think, squares? Why squares? What's the point of all this? And it's because we're doing a form of what my robotics mentors would call cartoon CAD. What basically happens is we take these squares and things and we make a simple sketch of what we plan to do. Once we've sketched out what we plan to do, we can then actually go into a part studio to actually do it. Alright, yeah, you're gonna be 2 inches. So, what I'm thinking is that we have a 2x2, and then it just has a bar inside of it that can slide up and down alongside the inside of it. A reverse climber, if you've been in first at all, a reverse climber, if you will. So it'll slide up and down, and when it pushes down, it'll have the wheels and stuff on the bottom of it. It'll just push the robot up. We have 4 of these. They work with each other, and that's the plan, basically. That's what I'm thinking. And yes, there's a lot of things that are like, would this work physically if this was made physically? Thankfully, I'm not making this physically. So we can just say it works first try, even though it would be so heavy and so much more thought that we need to put into it. We can just grab, like, I don't know, like a motor and just slap it on and be like, it'll be fine, because I'm not making it physically. If I were making it physically, then there'd be a lot more calculations and stuff that we have to do that I'm not going to bother doing, because I'm not making it physically. Those calculations and stuff we will end up doing for things like the mechanical hand, but this is not like that, so this is fine. Anyway, now that we have this, what we're going to do, we're just going to extrude a couple of boxes here. I'm gonna bring it up. How much do we want it to be able to go up and down? I feel that if we give it a foot of clearance, right? From here to 36, that's 35.5. I thought this was a yardstick. Why doesn't it go up to 36? No. You telling me that I don't even have a yardstick? The stick is less than a yard long. Since when? Come on. I couldn't even get a yardstick. Man. That's most unfortunate. Anyway. We'll just go from 35 then. This here is 1 foot of distance. I think going 2 feet. I think if we can put it, we're gonna go 1.5 feet. And the reason for that is, we'll bring it up to 20 because there might be some stuff at the top. The reason we're going 1.5 feet and not 2 feet is just due to the fact that I worry about when you're lifting it up, you have to consider the center of mass. You are changing it. And so if it's lifted up, it's gonna be easier to topple. Because that center of mass is way up there now. We could counteract this by like having it leave behind something on the ground as a kind of anchor point so that you can't topple it, but that kind of defeats the purpose of it being able to move away, of it being able to move like that. So for that purpose, we're just going to let it be that 2 feet, or that 1.5 feet, which is still, that's quite a bit of distance in the air. Especially considering that the robot itself only has a base of a 2x2 base. But hopefully we can counteract that with the treads. We're not doing swerve drivetrain today. This is going to be a tank drive for sure. Okay, so motor assembly. So we'll probably have a 2x2 corner cut out that the tubes go down into. But in order for them to go down, we need something that'll give enough pressure to push it down. Either that or we could attempt to pull it down as well. It's a lot tougher doing it this way than it would be to go up. Because up, there's nothing going against us, really. There's barely any weight that would be going against us. We're pushing air out of the way. Down, it's not like we're pushing air out of the way. Instead, we can't push the ground out of the way. Instead, we are going to be pushing the robot out of the way. All the robot's weight. I said we weren't going to worry about weight and stuff. Yes, there's still going to be some worry about weight and stuff that we have to consider. And, yeah. So, in order to push it down with enough force, what we would do with like a climber or something like that would just be have constant force springs. That's not going to be enough. There's not going to be enough force to push that down. We could, this is a D&D build, right? We could just like say it away with, it's like, oh, it's just, the motor works off of magical energy, so it just has enough to go, and no, I'm not doing that. What we could try to do, and I think what we're going to have to do, is have a pulley system down at the bottom here that is attached to a string that goes up to the top. And that string pulls down around the pulley system, pushing it down. What that will allow us to do, of course, is to use gearboxes and stuff to apply more force and pressure. So I think that's what we're going to have to do. And since that's what we're going to have to do, the motor assembly is going to be at the bottom. I would like each of these to have their own independent motor assembly. And that way, based on the, we can adjust based on on the ground that's traversing over. So, we're going to go ahead and give another little box here. Boom, alongside each one of these. And this little box is just going to be stuff for the motors, for the motor assemblies and stuff. I accidentally linked these two together, did I? Yes, unlink please. Thank you very much. But that's what this box will be. This is motor assembly stuff. And oh, hello Smev, you are alive. Welcome in, welcome in. Yeah, this boxes will be hello. Yes, I'm making stuff now to make your life difficult. Yeah. So these will be where the motor assemblies go. There we go. And then for the motor assemblies, I imagine the motors and gearboxes together, I don't think they'll be more than 4 inches long. In fact, what we'll probably do is put the motors this way. No, it would be make more sense to put them that would involve some gearboxes out because motors are gonna have motor shaft that outputs that direction. And it would be best if the pulley went sideways, was sideways like this, because that way it would just wind around that way and pull it down. If it's sideways, if it's winding that way, it makes it easiest to make the motor this way. We can just slap a gearbox on the end of the motor and it does that way. But then we're taking up space over here. It'd be great if we could just have a package that runs along the side. In order to do that, we'd need the motor. We have the gearbox on the front. We'd need another gearbox that goes and turns it, which isn't too difficult to do. But that does change this. This isn't going to be 4 inches now, because the motor itself is probably around 3 or 4 inches itself. So we're going to make this like 6 inches. And this width, we'll go ahead and make 2.5. There we go. And then that is that sketch. We can go ahead and go make a new extrusion for each of these. That will add on to their respective ones. Merge with you, 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 and you. And then this will go up another, we'll give it 3 inches. All right. And so now we just go ahead and insert this into the assembly. And okay. This basically just gives us an idea of like how much more space we'd have inside of our base plate. And honestly, that takes up quite a little bit of space we're planning if we do it like that. Thankfully, if we make these poles that go all the way up to the top, we can add some cross braces alongside them, and that'll, number one, give the robot body strength if it were to be smashed by something, because then we add on the side plates along the side, and that gives us a framework to work off of. That also means that we can have that framework for adding in the arms and things up higher up on the robot. So actually, that could be good, having that much length. It's down here that I'm a bit worried about, but then again, if we go back to our list of things that we need to be able to do, honestly, not a ton of stuff that has to be down here. We do want stuff. We'll probably have some like pulleys and stuff going down into this center area attached to motors just to try and keep as much of the weight as low as possible. It also means that we can like put the battery / power core down here in the bottom of the robot because we want to keep as much of the weight as possible down low. For a couple of reasons, of course. Center of gravity. When you're looking at this would be more of a combat robot. You want all the important stuff to be as central to itself as possible, and like if there's if you're on the ground and you're like only a couple inches off the ground, it's a lot easier to try and hit you from the side or the top than it is to get underneath you and try and get in from up there. So that also adds more security that way. Things that might any writing systems, I think we have. Honestly, I think we don't need to change the base plate size that much. I think a 2x2 foot square will work quite well. I think this will be fine. So now what we'll go ahead and do is we will start working on the parts for this. First things first, let's go check out that 2x2 pipes, shall we? How thick of a wall? We'll go with, we do want strength here, so we'll go with 1/4 inch. That works fine. Get rid of all these, make the sketch. Boom. Equal these. 2 inches, very good. All right. And then we have another one. This is going to be 1/4 inch. So we just do like so. Almost perfect. We just need to reverse this like so. And that is our first one. That gives this space to be 1.5 inches. Maybe not a 1/4 inch, actually. Yeah, let's do 1/8 of an inch. Let's do 1/8 of an inch. I will say, I do like the fact that when I'm doing this now, I do like the fact that I changed it so that I'm looking at the monitor over here, and I can like see chat messages when they come in and immediately pop up and stuff, and I can see stuff happen on the screen. On one hand, I like that. On the other hand, it does mean that I sometimes am clicking on the monitor that I'm looking at OBS, and so I'm clicking on OBS thinking that I'm clicking on the other monitor. And I'm not. So then, all right. That's the thing that just happens sometimes. You know, what are you gonna do? Oh well. All right. So we already decided that this is gonna come up 1.5 feet. That's 1.5 inches, not feet. There we go. So that's our tube. Now inside of it, we're gonna have another tube. Wow, who could have thunk? We have space here from here to here. That's okay. How many more tubes do we want? So, right, we could just do 1 tube. Or we could do more tubes, which would make it more complex. That would mean more pulley systems to go through the tubes so that it extends the tubes correctly. We'll just do 1 tube for now. For now, we'll just do 1 tube. So we went with, oh, interesting. We don't have a 2 by 2/8 inch thickness like that. That's unfortunate. I'm gonna go up to this one then, 0.188. There we go. And then inside of that, there will be another tube. And this one will be the, here it is. 2 by 2. This one will be 1/4 by 1/4 because that is the next size down. So, grab you. 1.25, 1.25. There we go. And that's the same distance apart, 0.188. There we go. And we can go ahead and just make this extrude both of these. So there are our tubes. Now we are going to need to add in some hardware to this tube. In between here, some spacers and things to allow it to slide smoothly. We have 0.187 inches to work with there. So what we're going to do is we're going to make a custom bracket that can hold some marbles in it. And that way the marbles push against the outside, making sure that's all good. I think that's the best plan here. There we go. Go ahead and, we do want to name. these sketches we do want to name. We do want to keep track of these sketches. The other ones, not as big of a worry. These, big worry. We want these sketches to be kept track of, yes. Okay. So we got let's see here. This sketch here was the, this is the tube sketch. And then this is the tubing extrusion. Very good. And so now we'll go ahead and make a new sketch. And we'll use that face. Good, good, good. Flip this over like that. We don't need the origin or the top showing. And this is going to be the bracket sketch. Okay. So we can use the same bracket for the top and bottom because we just need the bracket to push out to do things. However, we do need it to hold a marble. Let's go ahead and check some marbles and see what we have as far as that goes. Both springs and marbles, actually. Because we need a spring to push the marble out to ensure that that's working. Do we want it to be a marble? Do we want a marble? So the positives about a marble, right, is that if we were to look at this from the top, right, with a marble, we could like put it in the corner and have it push against both. Then again, we will have the bracket here. And that would add pushing, so we could just have a wheel that comes out and pushes against it. That might be better. That might actually be better. Yeah, I think that would be a lot better, actually, to just have a wheel that does that. I'm going to go ahead and use this real quick. So if we, like... If we had a wheel... 2 wheels of the same size... and they would push out against these walls. Let me go ahead and use this. We'll go ahead and make these tangent real quick. You tangent to you, and you tangent to you. Okay. So we have some wheels that push against these walls. I would push out on those. We do need 2 of them because that way they can just roll along, and we don't have to worry about them when they're pushing out. We don't have to worry about them like doing anything, like breaking things, you know. You might not know. Basically, right? We want the wheels to. Oh, you're gonna. Yeah. Let's go ahead and let's look at let's look at wheels real quick. These are going to be really big, aren't they? Let's first off, the width that we have to work with for these wheels is 0.187 inches. Okay. That's 0.25. 730 seconds would be 630 seconds is 3/16. Oh wait, no, we're looking at wheel width. My bad. 3/4. Is that the thinnest we can go? Oh dear. That's too thick. That's far too large. That is far too large. I think we're looking for wheel bearings, actually. Yeah, I think that's what we're looking for. This here. So, outer diameter. 7/8 of an inch, 7/16, 15/16, 3/8. 7/16 is still almost half an inch. That's still too big. Oh. Oh dear. Oh no. Uh, well, this is bad. Because we don't have enough space to be able to use any of this. Let's look at marbles. We might have to do marbles. One 16th, 3/32. Yeah, we might have to use marbles. Oh dear. Yeah, it's bearings. Yep. Oh, it's 500. Okay. I was about to be like, man, that's expensive. Well, I mean, it is, but okay. Okay. I guess we're gonna be making a box that we bolt onto the side that holds marbles in it. I think that's what we're gonna have to do. So yeah, these we can't use wheels then. We can't use wheels. We just can't. We're gonna have to make a box, which is yeah. Okay, that's I was hoping to not have to do that. Great. I'm supposed to annoy Smev with this, not myself. Um, all right. So here's the plan. We go ahead and we make a box like so, right? Now, the tough part is that we need the marbles to be pushed out. Yeah, ball bearings. Exactly. That's what we're gonna have to use. We need them to be pushed out both sideways this way as well as this way is the issue. Let's look at some springs real quick. Let's see what we've got that way. So compresses narrows the width of 2 R's. Tight space compression. That's definitely what we need. That is what we need for sure. Battery holders and push button switches. Okay. The outer diameter would need to be incredibly small. 0.125 might be too big. Just normal compression. Okay, that's fine. Compressed length at maximum load. Okay. This, I can work with these. I can work with that. Okay. All right. Got it. Okay. Plan. Here's the plan. We got a plan. This, we make... Man, this would be a pain to put together if this was actually being made in real life. Goodness. We make a bracket box. In the bracket box, we put these. And these should not be... Oh, great, I'm still on this tool, aren't I? Nope. Oh, great. There we go. These should not be construction lines, because these are not... these should be normal lines. Not construction. Boom, boom, like so. Nope, it did not select things. We make this equal to this. Good. This equal to this. Okay. So we have one set of springs at the edges of our little box, and these springs attached to this plate, pushing it out, pushing the bearing into the side. That way the bearing is up against the side. We have another set, kind of a bit more inset here, that pushes it out against this side. Very annoying to make and assemble, but hey, I'm not assembling it. So it's fine. Oh, goodness. Let's go ahead and get... One nice thing is that we can make this relatively big. We can make this whatever size we want here. I will say I do want this to be... We won't decide on that yet. First things first, let's see here. We need to decide on what diameter bearing we want. In order to decide on this, we need to see what our distance is here, 0.187. So if we go to our bearings, 0.187 is... We don't want it to fall out. We don't want that. Generally, we only want a little bit of it peeking out. So if it's too small, it'll just fall out. Defeats the whole purpose. If we were to make it the same size, then we'd have problems with putting in the compression springs on these sides. So we can't do that either. What we're going to do is we're going to take this number, 0.187. If we multiply that with... If we choose something that is 3/4 as large as that, 0.187 divided by 4 would be maths. Come on, brain. Kick into gear. That'd be 0.04. 27 would be... That's almost 28. Which is, with 4, that's like 6 or... Brain. Come on, brain. Half would be 5. So why would that... 4 times 5 is 20. So why would you say that 28 is 6? No, it's going to be 24. It's going to be 7. That's going to be what? 0.047. We subtract 0.047 from it. That gives us 0.14. So we're looking for marbles that are around 0.14. Before we say that we're looking for that, let's go back to the sketch. Let's cartoon it out. Cartoon cat it out. We're going to make ourselves a little circle here of 0.14 size. This would be riding along of that. pushes into that, right? I kind of want that larger. Honestly, I kind of would like that a little bit larger. The tough thing is that it has to be able to, unless we just have another bearing size. I'd like to just keep the bearings all the same size though. That would be preferred. So we'll go with that. We can work with that. We can do things to still make it easier to actually insert. So that doesn't get, so that just kind of slides into place. We can still do stuff for that. So that it's not an issue. We can make it work. It'll be fine. It'll be fine. What's the worst that could happen? Let's go ahead and go over to marbles. So 0.14 is what we're looking for. Looks like our closest is, unless 9/64 is 0.14. Is it? I can't remember. 9/64. 9 divided by 64 is, I don't think it is. Because 9/64 is going to be maths. Like I have a calculator. This is why calculators exist. Why am I doing stuff in my head? Why am I doing maths in my head? I can just, that's 0.140625. Okay. We'll go with that then. 9/64. I will go ahead and download your step file. Thank you very much. Yes. Yes, I will take that. Very good. Okay, that's our marbles. Let's see here. We can go ahead and we need to set up an import, don't we? We need to set up an import folder. Okay. So we'll go ahead and import that. Okay. Here it is. Combine to, didn't realize I could probably just import it straight into, I think this will allow me to just import straight into the studio, right? Did that work? Something tells me it didn't work. At least not the way I wanted. Because I'm not seeing it. Oh, I should probably name these outer tube and inner tube. Yeah. Yeah, where did my bearing go? I just imported. Oh, wait, is it importing right now? Oh. Oh, it's importing. Okay, that's why it hasn't showed up. Okay. Come on, just import. Hurry up. I know you can. It's fine. You can just you can come in. You can import. Come on now. How long are you gonna take to upload? I shouldn't. I pressed the wrong button. I should have just. There we go. That's what we want. Created link. Where is it? Hello? Oh. Well, here it is. There we go. Our very, very, very small import. We're gonna go ahead and copy that and head back over to our Part Studio 2, which we are gonna also rename to leg. Now, this is a part that I can't ever remember how to do, and that's getting an import into the Part Studio. Because I want to use it here. Oh, I can organize by folders. I didn't know about that. That makes things nice. We'll consider that in a second. How do I get you over here? Does anybody use Onshape and know how to get an import into my Part Studio? Because I do not remember how. Let's see here. Yeah, I cannot remember how to get it in Art Studio. That is unfortunate. Well, we have it, and we'll just import it into the drive assembly when we import this whole Part Studio in. For now, we'll just do it with Cartoon CAD right now. it's fine. It's perfectly fine. Okay. Let's see here. So this, why is it moving all of this? Probably because of that. Okay, whatever. This, we are gonna have it be a distance of that. Very good. And because it is a distance of that, I should not be able to move. Oh, no, it just moves the whole thing up and down. No! Stop it! You're gonna be... an eighth of an inch away from that. Okay. Is it this side that I linked it to? Oh. Okay. There we go. That's what I'm looking for. That's what I was looking for. Good, good, good. Okay. So what we're going to do is we're going to go ahead, because we want this to kind of have a little bit that it goes into probably about that much. Yeah, we probably want that to go in that much, don't we? So this and this can be tangent. One of which must not be a line. I see, I see. And yeah, point does not work either. Got it. That's fine. I meant coincident. That's what I meant. Because coincident is points. There we go. Okay. And so what that will let us do is that we can then increase this. So this will go slide up and down a tube. And in order to do that, we'll just go ahead and add in a little bit of a line here. We'll just let it go that far for now. Go back down. Go back over like so. Make these two lines coincident with each other. And then we can just give this line a size. 0.2 as well. There we go. And this is our tube that the spring will end up going into. So we'll put the spring in first, then we put on this cover, then we put in the marble, which we currently have no way of ensuring that it doesn't just get shot out of the tube. Oh, I should have thought about that. Okay. Oops. Well, what we can do is we can just go ahead and allow the tube to be a bit closer. It's so close already. It is right there. But doing that means that we can now add cap cover right here. That cap cover will go just a little thing that we can glue on or something, and that will hold this in place. Because we just need to make sure that's not wide enough of a cover that the marble can pop out. That's what we can do. Easy enough. Honestly, this tube should be thinner. Our marble's 0.14, right? So if we make tube 0.15, because we don't really want the marble to slide out and gets lodged into the tube either. We don't want that. So the tube should be thinner overall too, just like so. This space in between back here. And then right here is where the spring will go. Let's go ahead and take a look at springs. We're looking for an outer diameter of 1.15 or lower. There we go, 0.148, that's fine. The length, the smallest length we have here is 1/4 of an inch. This length we have right here is, okay, so yeah, 1/4 of an inch. That's at full stretch, right? It's 0.16 when it's pushed all the way in. Got it. We don't want it pushed all the way in. We don't want it to be at full stretch right here either. We want it to be pushing some, but not all the way. So if the marble is pushed all the way out, hold on a second. Let's go ahead and move this so that we can just do that with tangent or coincident. Yeah, go and make that. No, you need tangent. My bad. Okay. So if the marble is against the wall, this needs to be at least 0.148. We're gonna say, no, wait, it was 1/4 inch. And then 1/6 was the biggest. So we're gonna give it there we go. It's a little compressed, but it is not fully compressed. That also gives us space to be able to push down some when we're putting on the marble containment cap. Man, that's gonna be tough for the other spring when we get to that one. Oh dear. I am not excited about having to do this sideways bearing. But we're not working on that right now, so it's all fine. It's all perfectly fine and will not blow up in my face, surely. I mean, why would things ever blow up in my face when I'm trying to do things. Anyway, we just need to go ahead and copy over some of this stuff now. We'll just make this. Where is my equal tool? There it is. This equal to that. How much did I say? 0.05? Goodness. Tolerance on this thing are not loose, that's for sure. Good. Add in another ball bearing on this side. And we'll make it stick that into there. Put that right there. Do that to tangent. Good. All the sizes should be the same now. Okay. Now, we need to look at the side. Oh no. Oh no. The side is going to be tough. Goodness, the side is going to be very, very tough to do. Let's go ahead and extrude this first, right? Let's do that first. Before we extrude it, we need to go ahead and add in some points that we can add in a hole to. So we'll just add a line that goes across. Add in a couple points. And that way we can put in bolt holes. One to the side as well. Okay. And these are going to be... Actually going to put one there. One there. Now we can just make these midpoints, because that looks nice. Midpoint. Midpoint. Midpoint, though that midpoint will probably disappear when we start adding in that hardware. Very good. So now we extrude this. Oh, no, before we do that, one more thing I want to make in this sketch. In order to allow it to just slide in, what we're going to do is we're going to add in, or rather take away, right here. We're going to add an angle so that it just slides right in. Like so. That'll make it easier for us to put it together. If we were to put it together. We're not putting oh man, I'm not making this. But if I was, this would make it easier to do. We're also going to do that up here for the sake of symmetry. Oh man. Okay. It is a good idea when you design stuff to consider how you're going to put it together, because if you don't do that, oh, you're going to be in pain. That's the only way to put it. Absolute pain. If you don't consider the how, yeah, it's pain. Don't ask me how I know. But anyway, that should give us the ability to just slide it in. Because when we're putting it in, it'll kind of center itself. Boom, easy. Now we can go ahead and extrude this out. This is going to be a tougher extrusion. Go ahead and turn off section view. All right, so we want this to extrude out. And the extrusion needs to be of a size that it doesn't get in the way of... It can't... 0.5 away. It wants, and I want to be 0.5 away from that, which is going to be a pain to design around later. Oh, man. Okay, anyway. It's fine, it's fine, it's fine. It's all fine. It's great. It's all fine and grand. This is going to be something new, because this is a bracket. Okay, so this, we go ahead, we say up to this face, like so. And then we say, actually, no, I want to have an offset of 0.05. And that is going to leave me with a size here of 0.137. Oh dear. That's not going to work. No! Okay, I mean, it's fine. We can just go in and change the marble that we're using. That's unfortunate, though. No, 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 because it needs... Oh, dear. Oh, dear, oh, dear, oh, dear, oh, dear. Okay. It's fine. It's all fine. Everything is fine. 1/8.125. I don't like that. Okay, it's fine. Everything is fine. Everything is perfectly fine. That is still really close. I don't like that. I really don't like that. Because we can make this big. We can make that closer. We can make this a tad bit closer now. Okay. Yep, it is closer, that's for certain. It's definitely closer now. Man, I do not like that. I really, really don't like that. Okay. Small things are harder to put together. I know that I'm not putting this together, okay? I know in my brain I'm not putting this together. But at the same time, I'm designing it, and putting together smaller stuff can get very difficult. And in my brain, I'm just thinking, no! No, why? Okay, we're fine. It is all good. It's all fine. It's all fine. It's all dandy. We're good, because we aren't actually putting it together. I just need to remember, I'm not putting this together. I don't need to worry about that. Okay. Let's go ahead and show this again. What? What? Listen, you're not putting it together either, okay? All you're doing is watching me talk about it on your stream, taking up your stream's time to talk about it, okay? That's all. You're not putting it together. I'm not putting it together. Nobody's putting this together. If there's any first teams watching, do not build this. Oh, you'd better not put it together. Okay. All right. Let's go ahead and see here. This, that, 0.3, yep. And then 0.3 will be the ball bearing is 0.125. So we have... Okay, I get it. Okay, yeah, I see. So you'll have whoever is playing, if I decide to try and make some sort of change on the field, you'll have them roll a very difficult dexterity check. I see what you're saying. Okay. Oh, of course you will. Fine. I mean, fine. That makes sense. That does make sense. Goodness, that bracket is... There's not going to be much space there. Oh, what? Well, okay, whatever. It's fine. It's fine. We're all good. 0.125. We have 0.157. Divided by 2 to 125ths. Man, that is very little. It's fine. It's fine. What's the worst that could happen? What's the worst that could happen, right? Surely nothing bad will happen for me doing this. Surely nothing bad would ever happen from me designing something and the DM watching me design it. Surely. What's the worst that could happen? Surely the DM won't watch me design it and take my design and use it against me. No, that would be silly. Okay. Add that. No, I'm not going to do that. What I'm going to do is do this. I'm going to make this a removal. You're going to go up to this face. And I know you're going to be confused because there's nothing to remove yet. But don't worry, I will fix that. Oh, it can't show the custom emojis in the window. That's very funny. Also, my camera just went fuzzy. Come on, camera. I'm right here. That's very funny. Just the custom emoji just writes out to Mabel. That's very funny. 0.016. There we go. I know you're confused. Don't worry. That's because this is all coming out too now, and now you're not going to be confused anymore. It'll all make sense. Boom. See? It makes sense now. And so now we can, now that we removed all that, we can extrude all this again. This is going to be the inner removal. There we go. And then this will all be the next one. 0.16. Very good. And then this is the man, I should learn how to spell someday. I'm spelling everything wrong. Let's see, this is 0.125. This is 0.15. 0.125 is the size of the marble. I don't think I want it to be that size. So we're going to go ahead and give ourselves a little bit of more distance on both of these. Instead of 0.16, we'll do 0.15. We're dealing with super tight tolerances already, so it's all fine. So now this is going to be 0.127. We'll just do 0.1. Yeah. That's what we'll do. Bringing this up to 0.137 and this up to 0.15. There we go. Okay. We have this. Now we just extrude a new part. Is there any possibility of this part getting jammed is the thing. So we don't want that. We don't want this part to get jammed. As long as it's thick enough, I don't think it'll get jammed. I don't think there's an issue with that. We do need to add a little bit of distance between the two. But as long as it's thick enough, I don't think we'll need to worry about any jamming. Oh no. Fucking stuff over. Because the issue with jamming, right, is if you have a part that is sliding through another part. If you have a part sliding through another part, that part has some wiggle room in order to be able to actually slide smoothly. But if it has enough wiggle room that... do I have something over here that has wiggle room? If it has enough wiggle room that it could go like this, it might end up getting jammed because it's going the wrong way. If it can't rotate like that, though, you don't really need to worry about it getting jammed. It's not something that can happen. So, as long as it's thick enough, should be fine. Shouldn't have to worry about any jamming. We extrude you. We make you... How big were we looking at making you a second ago? 0.04 is what we said. Should be fine. You are new, and you are 0.04. Good, good, good. And then... we go ahead and... we're not going to worry about that, actually. We'll do that afterwards. We'll have to make a new sketch, but it's fine. It's fine. Yes, it is fine. Okay. Brain is thinking many things. But many things are not catching up to... Brain is thinking many things, just not English. So sorry if Brain thinks something and doesn't say it very well, because Brain not thinking English. What is this? This is the bracket, I believe? And this is the... what would this be called? It's not really a piston. The bearing push. Okay. Now we go ahead and just thicken this, but we're not actually thickening it, we're actually thinning it. Not loft. Thicken, there we go. Oh, you didn't... okay, well, whatever. Oh, that's more than I was hoping. Yeah, that's a lot thinner than I was thinking. Let's go ahead and, we don't need a lot for it to be able to slide smoothly. Okay. That'll slide smoothly in and out. Perfect. Good, good, good. And then last thing we need to do, we need to go ahead and add in another sketch here. Sketch plane of view, go ahead and borrow you as well. Add in a construction line going across with a point in the middle. And that'll be the point that our circle is going to emanate from. like so. And for the size of the circle, we need to go back to the bracket sketch. From this point to that point. Yes, you're opening the sketch. Thank you very much. Okay. Let's just make these construction points. From there to there. Good. This distance is 0.9. We're just going to say 0.92. That's fine. As you can see, I'm getting into this, and so now I've begun to stop naming my sketches and things. I stop it. That's not what I'm trying to constrain. There we go. And we make this go, that was going halfway through this, right? And this is 0.4. So this is going to go down 0.2. No. Yes. 0.02. Remove that much. As such, we go and section view this so that we can take a look at it. Where's my things that I can actually, like, where's my thing gone? There it is. Why are you so low down here? I need to be able to see what I'm sectioning. Okay. There we go. So that'll hold the bearing in place. I'm gonna go ahead and just do this real quick. Okay. Yes. Oh no, section G. Wait a second. Get out of here. Get out of here. I don't want you. Okay. So that holds the bearing in place. Put the spring in first, then the bearing, or then this plate, then the bearing, and then a cover plate, which we need to make next. Gonna go ahead and make a new sketch. You are the sketch plane. This plate will go up and down here, and then it'll hold the bearing in place. So we make the plate. We can make these and this coincident. And then for the... We can also make these coincident. No, we're not going to make these coincident. Instead, what we're going to do... I just had an idea that was probably not brilliant, but I sure think it was. We're going to do this, and then we're going to make this plate inside of it. And that way, we don't really have to worry about it rubbing up against the outside or getting caught on something if we're trying to put it in. That way it's just flat here and it just slides up and over. Genius. Till I realize it isn't. But I haven't realized that yet, so it's genius to me right now. It's all good. For the... Can I look at this, please? Thank you. For this, up here, we're gonna go ahead and take a look here. Let's take a look-see. Let's make a new construction line. Gonna go down that way, perpendicular. Good. Distance is gonna be 0.01. Reason for this is because I need to know what this size is. so that I can figure out how big of a hole needs to be made in the plate. This distance is 0.117. Okay. We'll make it yeah, we'll just make it 1.1157 is fine. Okay, cool. So this sketch then, we go ahead and we grab another construction line going across. That way we can get that center point. Make our circle of 0.117. And we also are going to go ahead and grab a construction line going straight up and down. The purpose of this is that we can get a couple of points on this that we'll put holes at later. You go there, because midpoints are nice. There we go. Okay, good. Very good. We remove from this 0.01 like so. And then we take the sketch and we extrude 0.01 in the reverse way. Boom, that gives us this new one, which will be named the bearing faceplate. Okay, very good. And now we just need to go over here and do the same thing. Over here, we go ahead and we grab our stuff, like so. Good. This right here, we need to add in that. Like so. Oh, I forgot to grab that A. Okay, that's fine. Oop. From over here, there we go. Then we grab this, add it back in. Very good. We take the bearing push, we make a copy of it. Transform by mate connectors. Copy the part. We're going to take it, let's go and hide all that. There we go. We're going to take it from not that one. Delete you. Not that mate connector. Not that mate connector. We're going to take it, we're going to bring it to you, and we're going to take it from, get rid of the bracket. Oh, no. Taking it from you to, bring the bracket back, you. Reverse it. Like so. There it is. Very good. We need to remove from over here too, don't we? That is a thing that we have to do. We need the square, which is done 0.137 and 0.26. This is 0.01 as well. Okay. So over here, we'll just make a new sketch and do the same thing. .01, 0.01, Very good, very good. Bring you over to, where's my coincident? There it is. You connect to you. And you connect to you. There we go. Very good, very good. We move this sketch up here. No, we don't. I don't know why I did that. We remove 0.01 as such. And then we can just move the bearing faceplate. We can go ahead and copy that now. Translate by line. We are going to translate by XYZ. Yes, yes, by XYZ. And we just move it over here. Okay. And that is that part of the bearing. So that'll push against the sides. And now we have to design the part that pushes. Okay, okay. Now we have to design the part that, oh no. Oh dear, okay. It's fine, it's fine, it's fine, it's fine, it's fine. Everything is fine. What? Okay, oh dear. Let's see here. From here to here is a parallel distance of 0.475. We'll go ahead and make our section view that then. Oh wait, can I not? Ah, there we go. Opposite way. Was it 0475? No, it wasn't 0475. That doesn't make any sense. Did I misremember? That makes the most sense. Let me see here. What is this? This... Oh, well, that's what I was trying to do. I was trying to do it down to that point anyway. So that all works out. Okay. Then we need to put in a bearing for this. We don't have much space to work with. In fact, one might even say we have no space to work with. Oh dear. Oh dear. Oh no. Okay. We'll make a sketch from you. And then to start out with, we'll grab the side. And we'll also hide these tubes. Very good. And we'll grab that side. We'll also grab the innermost sides of both of these. Okay. Here's what we have to work with. Indeed. This up here is the top side. And that's what needs to be pushed out. To start out with, let's go ahead and figure out where we want to place things. So we want it to be equal distance apart. We'll start by going ahead and putting a midpoint there. then 2 more midpoints. And we'll put 1 at each of these midpoints. So we put 1 bearing here, we put 1 bearing here. That's the plan. Our bearings, we go ahead and draw out a bearing here. They're 0.125. Oh no. No, 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 no. Oh dear. That is not good. Oh, some might even call it bad. Yeah, some might even call it bad. That it's so not good that some might call it bad. Okay, oh dear. Okay. It's fine. It's fine. It's fine. It's fine. We just have no room for a spring. Goodness. Absolutely no room to try and fit a spring in here. Like, if we just put this over here... Can I... Why are you frozen? No. Whatever. Delete that. Bring you down here. And now, I'll make you tangent. How's that? Happy? Okay. Well... That's kind of tight, isn't it? To try and fit a spring down there. That's kind of small. Once again, I'm not making this thing. Like, right. This is very possible to make, right? It ain't easy. So we need a block and then the spring. Okay. Sure. Sure, why not? Why not? What's the worst that could happen? This distance here, 0.01, 0.01. This bracket has to be made out of some sturdy metal in order to... Oh, goodness. Okay. I don't need to put in this one. I can make this one an equal. That's fine. If I was designing this as something that I'm trying to build, I do not have the parts or the means to make stuff this small. This would be such a... Oh, oops. This would be such a different build design. We designed it so differently. Because I have the freedom to pretend that I have the parts, I can design it like this. But goodness, is that small. Like, that's... Hold on a second. Let me get a smaller unit of measurement just to get an idea of how much space. That is such a small amount of space. That's not even 1 millimeter. That's so small. That isn't gonna work. The spring is gonna bust that. this how strong is that metal for the spring to not just bust it? That is less than 1 millimeter thick. I think it's less than half a millimeter thick. And like over here, sure, it's just the walls. It's whatever. But the spring is applying pressure to it. That's like a quarter of a millimeter thick. So stupid. That doesn't. That's not how things work. Um. That being said, we just need pressure applied. Doesn't necessarily need to be a spring. We could put a piece of rubber in there to just apply some pressure, right? And the issue with the spring, of course, is that it is very concentrated. The rubber is more generalized, so it would be fine. Also, rubber can be made much smaller. But we can just, like, change this to be... Oh, actually, I don't need both of these either, now that I think about it. I can get rid of you and just make you guys horizontal. Okay. Make it at least a 1 millimeter thick. And then just, like, put in a piece of rubber there. So yeah, I guess this one just has a piece of rubber underneath it. Which is fine. What we do is we take... This is how big? What? 1.15, okay. We take our bracket, go ahead and show that. We extrude. We remove the bracket. Extrude this and this opposite way. We're going to merge it with bracket. And then this will not be an inch, it'll be 0.15 inches. Excuse me, that was a removal, right? Why are things looking so weird? And like, what part got made? Where are you coming from? What are you? Oh, you're another bearing faceplate, aren't you? Oh, wait, it's being wacky because... Okay, never mind. I know what that is. Never mind. That's fine. And actually, before we extruded that, we... Nah, never mind. We go ahead and we take this. We make a new sketch along the side. We'll just take a whole big area here. It's fine. And all of this. Oops. There we go, like so. Add in a construction line. some points. Those become midpoints. Pardon? Oh, it's because I thought it was doing something else, I think. Why can you not be a midpoint? You are a point that'll be between two other points. It should be fine. You are constrained to something that you should not be. You're constrained to this line. That's not a line. What is that? No, wait, that is a line. Yeah, you can slide along this entire thing. Why are you complaining? Whatever, I'll just get rid of that constraint. It's fine. Why were you complaining? I could have just slid you over there and you'd be fine. Okay, whatever. It's fine. Okay. So that will give us that plate. Yes, it will, because we can use the same diameter over here. If we look at this diameter, that is 0.117, right? Yeah. We can just use that same diameter. It's all good. Okay. Construction line. Construction line. That should not be construction circle. Oh. Boom. That should be a normal circle. There we go. And then we make a new circle over here. Make these circles equal, because that way we don't have to change as much stuff. And 0.117. Okay, and that'll be that faceplate. First things first, we go ahead and remove the bracket. Then we go ahead and make our new faceplate. There we go. Good, good, good.
Get water! You need water now! Get the water! Hurry up! You don't understand? Tú necesitas agua! Mizu ga hitsuyo desu! Get it! Chug! Chug! Chug!
Hello, Cal. Welcome.
Oh, goodness. I need water after that.
I'm getting water. Hello, Cal. Welcome to the stream. Yes, Cal. It is loud. It's always been loud. That's the point. Guys, stop making me drink water. Don't make me drink water. It is super loud. Don't make me drink water. Just don't make me drink water, okay? It's extremely loud. I don't want. No. Oh goodness. I was very focused and I'm almost out of water too. I'm gonna need to refill my cup soon. Don't make me drink water, guys. It's the water is healthy, the stress is not. Okay. Yeah, listen, the water is healthy, but the stress is not. Don't make me drink water. It can't can't be good for me. Oh, so okay. Anyway, go ahead, make some points. Oh, so loud. What? That is the wrong measurement. Goodness. That's not what I was trying to mention. I want to put you to you. Why? No, that's not what I selected. Why do you keep doing that? Work with me here. I guess if we do you to you, maybe? Oh, that's why. I know why now. Okay. Yeah, that's why. Okay. Never mind. I know why that happened. And then this here is going to be... There we go. Make a couple more midpoints. And then those are drill points for the bearing to be secured. So we're actually quite close to each other. I'm gonna change this some. Yeah, that's better. So this entire area is gonna get removed some of by point. That is too much still. How much do we? This is point like 1.5 thickness, isn't it? So like point. Okay. And now we can go ahead and add in some holes. To start with, you and you. You go... I'm not gonna say through all. I'm gonna say... terminate here. Start... There. Goodness, this is a small bracket, that's for certain. We're gonna need some much smaller screws. Eighth inch. There we go. Extremely small screws. And actually, you're gonna terminate from... Your termination will be there. These are like specialty screws, goodness. Because of that, I'm not even gonna bother like screwing these in. That's just gonna be glue. That's gonna be glue of some sort. Okay, and so now we actually, this here, we can just go ahead and terminate on the other side. And then we could go ahead and copy you, all of you, by XYZ. we copy from, not XYZ actually, we're going to do it by mate connectors. That one to that one. There we go. Very nice. That's our bracket. To make sure that stays sliding correctly. That's the upper one. We then duplicate that down here for the lower one as well. But there's some other stuff that happens at the lower first, because we need to be able to actually pull it down, up and down. And there's a reason that I made the bracket like this instead of going all the way around. That is due to the fact that this gives us room here for a cable to slide alongside it. And if we have room for a cable to slide alongside, we can come down here and we can make an incision right here for it to slide out of. And that's exactly what we're about to do. If we take this sketch, we go ahead and we make a midpoint here. And then we can just, it doesn't matter the length here, because it's just going to get removed. Remove a few inches, just to give us some space to work with. Go ahead and round off the edges, as such. There we go. This down here will round off as well. Okay. Good. Now, when it pushes out, we do want to put a limit on how far out it can push. And that limit will probably just be where that other bracket is. So if we look at the inner tube itself, this is 1.5 feet. If we go up, just make a construction line real quick. This is 1.5 feet long. If we go up 1 foot, that would be around there. That'd probably give us 10 inches of up and down movement. I'd like a foot of up and down movement. So if we change that to be if that's the upper part of it, I think it can work with that. I think I'm good with that. That's the upper of it. So then we're going to take all the bracket stuff and move it down. Well, copy the part. That's like 2 or 3 inches, right? We'll move it 2 inches, that's fine. If we do that, then we can go ahead and take it and add the holes again. We're just gonna add them like this and remove. That's like the opposite of what I'm trying to do. Fine, whatever. It's fine. We'll just take this, use you to get those points. Go ahead and put the points in place. And then use the hole tool. It's fine. Terminate it here. Good. And then copy all the bracket stuff again. And put it over here. Translate by mate connectors. There it is. U to U. Reverse. Rotate into the correct position. Just realized that that one is rotated incorrectly as well. We'll go ahead and fix that. There we go. So that is the brackets in place. Okay. So this smaller tube is the one that actually moves. The bigger one doesn't. What we are going to do, because we're going to pull down on the inside of the bigger tube, or we're going to pull down on the bigger tube. In order to do that, the brackets are there so that when it pulls down from a side, it straightens out so that it doesn't go out to the side when pulling down. Because we're basically going to tie from here, pull it down this way through here around whatever winch system we have here with the motors and gearboxes. Yes, okay. So to that end, what we will do, it would be great if there was a way to distribute it more evenly. Because right now when we pull down, it'll be pulling down into the side. Also, we can go ahead and add a blocker down here real quick. Just so that when our bearings get down to here, it doesn't do anything. They don't move. So down here, we'll go ahead and put in a new sketch, and that sketch will just be... That's the wrong type of square. From here to here. And then the size up and down is anything really, doesn't matter too much. An inch. Eighth of an inch away from the end, that's fine. Looking at this side, we can add in the construction line going across this way with some points on it. As such, there we go. And then this extrudes out 0.16. Yeah, that's fine. Not going to be added. That's something new. We go ahead and we take this sketch. We make holes. Here and here. They go up to here. And they start from right here. These holes can be larger, so we can go ahead and make these like 1/8 of an inch or whatever. There it is. And we can take this new part and we can copy it over by mate connector. And then we have blockers, boom. So it can't slide past those. And those can be out of whatever. They can be rubber or whatever. It doesn't matter too much. So then this here, if we put a pulley, I think we go ahead and we just put a hole up here that it'll go through, that the cable will go through and hook around. Down here, we'll put a pulley so that it isn't grinding against this metal here. We'll put a pulley down here. Oh, what did you discover with redstone in the new update? An AFK blaze farm. Does it drop blaze rods? Because the whole thing about that was that it has to be killed by a player to drop them. Unless they changed that. I don't know if they did. They could have. Okay, cool. Using lances. Okay, I see. Lances and mine carts. Got it. So you just like kind of go around and around. Got it. I mean, it's only as AFK as long as the lance lasts, but still, okay. That makes sense. Oh, we can make them custom? Oh, no, that's for your machine. Okay. Mending repair. Oh, that's true. That's true. Wait, you can put mending on them? I thought that you couldn't put mending on them. Timed auto clicker. Okay. So it's not vanilla. Auto clicker can be considered. It's not true vanilla, but it is AFK. Okay. Cool. Cool. If we have these close to each other, because this is basically going to be a guide for the wire. That's basically what this is. That's true. Yeah, that's true. I don't think I want nylon. I think I want metal pulley. I think I want steel. That's 125. So that could work. Because if we have a cable, a metal cable of that diameter. Yeah. Yeah, that could work. If we look from the side, we can go ahead and begin mocking up some stuff. So if we have a metal bracket here, that'll give us something to put the pulley on and the winch on, both. And then on the other side, we just connect it to the, because we're putting it here, we just connect it to this on the other side. So we only need to design for one side. Okay. Yeah, let's do that. In order to connect this bracket to this side, we can just put it through these holder ones as well. Because if this whole assembly can just be something that we just kind of slot in place, that would be great. That'd be preferred. Of course, that we aren't building this. I just gonna repeat again. We're not building this. This is not getting built in real life. I'm just designing as if it was. I cannot stress that point enough. I think we go ahead and just center the pulley. Hold on a second. How big of a pulley is this here? The outer diameter is 2.5 inches, or an 1/8 inch. 1/8 inches, 1, 2, 5. Okay, yeah. So 1.5 inches outer diameter, or 2.5 inches outer diameter. If we look at that, if we make a circle, we'll go ahead and make it a construction circle. That's fine. Okay, that is that size. So then we want it to just barely go into here. This here is the bottom of the thing. So if this goes to the midpoint, and then this rides along that midpoint line, how far do we want it from the bottom of the ding? 0.25 sounds good. And then we go ahead and borrow you. And you. I think we want you to be tangent to you. Yes. Yes, we do. Right? No, we don't, because we do want... Okay, got it. Understood. What am I understanding? Okay. What I'm thinking, right, is that we don't want this pulley to be tangent to the inside of this large one, because the whole goal of this pulley is to make sure the cable doesn't rub up against this top up here. So if it was tangent, the cable would still be running up against the top here, while before it hits the pulley and starts going around it. Defeats the whole purpose. So what we're going to do instead is, what do I have selected right now? I have point selected. We're going to go ahead and put it halfway between these two with another midpoint. Right here. And we'll make it coincident to that midpoint. And that way, we now know where to put this point here. For the, we're looking at this, the pulley shaft diameter 1/2 inch shaft. So we go ahead and just make a circle. There we go. And it's for that shaft diameter. So now the pulley does go inside of here some a little bit. It shouldn't touch this one. And it should have the cable come around it to the winch over here somewhere. This will be where the winch is, over here. So it'll come around this, go around this winch. Yeah. And then when we rotate it, this will come out. When we tighten the string, this will go, or when we give the string some slack, this will go back in. We don't need any springs or anything. We got gravity. It's going to push it back in automatically. When we loosen it, this will come out. Perfect. That's what we want. So we can go ahead and gonna go and copy these as well, just so that we can have those ready right there anyway. And just do that. Good. Oh, they do? Oh, lovely. I was fine with them spawning in super flat worlds, but did they fix it so that like the end is super flat now? Because honestly, that was always my issue with it. That the strongholds spawned, that's fine. I don't care. But the end wasn't super flat if you went through. And I just wanted the end to be super flat too, because if it's going to spawn, just make the end super flat. So did they fix it so that the end is super flat? Because if so, cool. I'm fine with that. I mean, that's expected. It is super flat world. I mean, what are you gonna do? Have it sink? Nonsense. Okay, so the winch, the, for lifting, that's is more weight. That's better. How big are these? These feel really big. 7.5 by 20.5. Yeah, these feel really big. I don't need anything that big. A weight capacity 600. I only need a weight capacity like 300 probably. That is. Oh, the end is normal. Oh, come on. That's no fun. Yeah, these are like heavy duty stuff. I don't know. Oh, a raid. Hello, thank you for the Lieutenant Cloflam? I'm not sure if I'm getting that right. Thank you for the raid. Welcome in. Welcome in. We're making things. Thank you for the raid. Oh. I just got that pops up on my screen. Oh, thank you for the follow. Thank you. What were y'all doing? Hello, welcome. Hello there. Welcome in. What were y'all doing? Hello, welcome. What did you just finish up doing? I assume that you did finish something. Oh, Flam's good enough? Cool. All right, Flam. Welcome in. Yeah, we're just we over here we're just designing a robot character for a D&D session. Well, what did you all just finish? Yeah. And what type of stuff do you do? Like, you do you do more gaming or like more of the bit of everything, video editing, science stuff, pedantal. I'm not sure what pedantal is, but okay. Lagrangian points. Okay. All right. Cool. Yeah. Most of what is done over here is more like at the moment at least is more CAD stuff. Mostly due to the fact that I have not gotten the medal and stuff for the actual putting together of stuff, but most of what I do is CAD except on the weekends, which is gaming. But no, that sounds really cool. Okay. No, yeah, welcome in. Welcome in. Uh that was surprising. Oh yeah, we are currently just Smevulark is another play different games? Oh, what type of games? Over here, it'll mostly be Minecraft or learning new languages. Yo, that's a lot of different things. That's really cool. Learning any specific type of languages that you enjoy learning, like the more romantic languages, or do you like more of those Eastern or bit of shooters? And okay, got it. Yeah, it's the games that we play are typically Minecraft. It's game over here, mostly just Minecraft. But no, that's really cool. Okay. No, yeah. So did you just finish up playing a game, or were you just doing you're you were watching, like, you're practicing German, but in the past Portuguese, Spanish. Okay, you are a smart person. Okay, that is more languages than I could ever than I could dream of. I have trouble with English. Okay. Okay, yeah, I just have trouble with English, I'll be honest. That's English is hard enough for me. It's like, oh no. Uh I can barely speak sometimes, and I grew up native English, but being able to learn that many languages is insane. That's fair. That's fair. That's completely fair. But I mean, still having that many languages that even you know a little bit about. I'm from Georgia, the state of Georgia, in the U.S. So English is my native language, but sometimes Englishing be hard. Englishing be difficult sometimes. How about you? Where are y'all from? Am I studying at Georgia Tech? I am not. I'm I won't say self-taught. I had mentors and stuff who taught me stuff. This is all just stuff that I have picked up. You're French, okay? All right. Yeah, this is all just stuff that I've picked up in first robotics and stuff, and then also some stuff that I've learned on my own. So I'm partially self-taught, partially mentor-taught and stuff. I'm not at Georgia Tech or any specific university or anything studying at any of those. Yeah, I don't I don't have any degrees or anything, but I do have I have my high school diploma, and I also have a lot of ideas, and it's like, I have ideas, and I want to try and see if I can make those ideas into reality. So, might as well give it a shot. Yeah, Georgia Tech is well known for technology and stuff. I'm not married. I'm not married, no. Um my high school diploma, not a marriage certificate. Yeah. Yeah, no worries, no worries. No, not husband diploma. High school diploma, my bad. Like I said, Englishing can be hard sometimes. Uh high school diploma. Yeah. No. Yeah, right now, all what we're just trying to do is Smev's putting together a Smev is another streamer, and I did not marry. No worries, no worries. Um, no, I live at home with my parents, and sometimes I lose my hearing too. Really annoys my mom when I do, and she was asking me to do the dishes. Um, but no, yeah, no things. It's cool. Like learning languages is one of those things. It's for me. It's like I'd love to be able to learn more languages. I'd love to be able to learn more languages. and I try to. I really do try to. But then I hit a point whenever I'm learning language. Oh, what is the dishes? That's when you're like if you're eating off of a plate or something. Uh, that's a dish. So when I'm doing the dishes, I'm cleaning the plates and the cups and forks and all that stuff. Yeah. But learning languages is difficult. Like you hit a point and it's like I know something, but getting over the barrier of learning more is just hard. Oh yeah. Yep. Yeah, yeah. Yeah, yeah. No, it's being able to have that many languages. So, I think you meant strong, right? Not string, but I get what you mean. Yeah, I get what you mean. You meant strong, yeah. But yeah, it's to those who are able to learn so many other languages is I salute you. You guys are insane. Let's see, how does this work? Turn the crank. We can probably take this, remove the crank, and then just put autocorrect. Yeah, autocorrect be like that sometimes. Slap a motor on it. This one's a lot smaller. It's what, like 3 5/8? Oh, that's still quite a bit. That's still quite a bit of stuff. Yeah. Let's see here. We could just make our own winch, right? Because we just need to put the motor, add a gearbox to the end of the motor, and then just attach that to the winch. We could just do it that way. That would be the simplest way. And then for the actual winch itself, we basically just need something that'll rotate and that just a metal beam that'll rotate and it'll go around. That's all that we need. We don't need an official winch or whatever. Yeah. It's so the thing I like about Onshape is it's online, so I can take it on the go, right? I can be working on documents on my phone, or on a computer. I can log in on a computer at like the local library or something and work on a document there. That's the really nice thing about Onshape. But yeah, it's a CAD program. It's like FreeCAD, and I don't know that I'd say it's like SolidWorks because I think because you can't really do any CAM with Onshape. And I think you can with SolidWorks. I haven't done much with SolidWorks, but with Onshape, it's mostly just CAD. Yeah, you can add in other like applications to do it. Is SolidWorks just CAD? I thought it was more. If it's just CAD, then yeah, it's Onshape is just a CAD program, but it's an online based, a web interface based CAD program. I think we go ahead and just add in another circle here, another 1/2 inch circle that'll go to. No, we'll make this one an inch. We have the space, and that also gives us room to put it through, to put a hole through it. Yeah, I put a hole through. Yeah. And then this and this can be an inch apart. And this to this. Yeah, should be fine. Also 1 inch apart. Go ahead and add in this. There we go. Boom. Boom. Good, good, good. Okay. So let's see here. What do we have? We've got the tube that goes through. We'll wrap the cable up here. It slides down along the side of the tube. It comes out here. Yeah, it probably does. Especially if you're, I don't know, if your engineering club did anything with FIRST, this is going to be very similar to that. Kind of what I'm basing this off of to some degree. Those types of robots are kind of what I'm basing this off of. This slides around this pulley.
Get water! You need water now! Get the water! Hurry up! You don't understand? Tú necesitas agua!
No. Okay, thank you, Cal, for the water. Please stop making me drink it. Please stop, Cal. Please stop. It is water, yes. It's, oh no. It's loud, that's what it is. Goodness gracious. I don't drink enough water during the day, and I also don't drink alcohol either, so. It is indeed water. I did just run out. So I will be right back. I'm gonna go and refill my water. I will be right back, guys. Give me a couple minutes. I'm back. I got a refill of water. Water is filled up. We have more. I'm not sure if you can actually see it well, but we got more. Please don't make me drink water. Please. It's painful, guys. It's loud. Oh no, Joltik, get back up. There we go. It is loud. Please, please don't. Okay. All right. Let's see here. What are we? Where were we? What were we doing? Ah, yes. Okay. This goes here, goes around the pulley, goes to the winch, that rotates around, and then we need a side gear to hook into the main thing so we can have it be. All right. See you, Flom. Thank you for the raid. Thank you so much. And I bid you a good evening as well. Actually, it might just be easier to put the. How far do I plan to go with it? With this, I'm hoping to finish this leg part up. I'll probably will stream for another. How far have I gone in total? Oh. All right. See you, Michael. All right. Probably I will go to. Right. This is I have a base plate, and then I'm working on the legs right now. So we haven't gotten that far yet. Honestly, we've gotten it. It has not been a ton that has happened thus far, but hey, it's fine because the goal is to. Once this is done, the goal is of course to make Smev annoyed. So it all works out. It all works out great. If it annoys Smev, then we're all happy. Everyone's happy. Right? That's the goal. If Smev is not annoyed, then yeah, I do drink the water. It's nothing to worry about other than my eardrums. I don't know if you're at all worried about my eardrums, but I mean, other than possible hearing damage, nothing to worry about. Let's see here. Make that a 1/4 inch. I think we'll go ahead and have the motor coming out this way. We'll probably put the motor right here, have the gears going over to it. I never want to put the point of stress on the motor shaft. The reason for that is because if the motor shaft breaks, your entire system, it's a lot more expensive to replace the motor with a new motor than it is to replace a gear, right, that bends out of shape with a different gear. So I'll probably put the motor off to this side, put the gears going up to here. That'll also let us make that the gearbox, and then that rotates that winch. That's probably what I'll do. I feel like that is a bit of a better plan. Yeah. That's. I'm thinking over this in my head as I say it. I think that's a good plan. Yeah. With that being said, we can probably. Do we want to insert this in and start putting it in place? I think we can. I think we can do that. Before we do that, I just realized this added, which was not what I wanted. I wanted that to be a new. There we go. Before we do that, over here, we're gonna make a new sketch on this side. We're gonna make a rectangle that goes up to boom, and we will do like so, 2 inches. So that is how much it interacts with the our base plate over here. That's how much interaction we have, since this is 2 inches. So we do want to put in some bolts. We take a construction line going this way, I think we'll do. Go ahead and put a midpoint here between these. And do a linear pattern. Go opposite way. Okay. So that gives us some points that we can work off of to add some bolt holes to. That's the opposite side from this. So yeah, it is free to add them there. Good, good, good. And then we are going to have to figure out where those line up with the other side as well. With the actual base plate, but we can do that in a second. That's fine. First up, that is... I think it'll be fine. We'll do one on each of those corners. And we'll do the third hole there, I guess. We'll bring it up to there. And we start from here. So a couple of holes, yeah, that's fine. And then that's how we'll bolt it onto the outside panels. Then this will bolt through here for that. We have... This will go through here. That's for shafts. I just realized this does not need to be that big. That only needs to be like... these don't need to be that big. The shaft is not going to go through them. It'll be attached to them. Why did I make them that big? Okay, whatever. It's fine. We'll just delete... Not. We're going to switch these over to being construction. And then we can go ahead and show this sketch. We can use these points and we can just add in our holes here. We'll start from part up to there. It is not wanting... There we go. Okay, yes, that's what we want. We want that hole there. Good, good, good. Okay. Also, I realized that when they followed, it did not... Tanks did not say that they followed. So give me a second here to start tanks back up. Subscribe to channel, follow. There we go. There we go. So when people follow, it should update that now, right? Oh, it did update it. Okay, it just didn't do the like follower sound up here in the corner. Yeah, it didn't do that before. Okay, whatever. I'm not sure why it didn't do that, but it should do that now. Should be good. Okay. Okay, so this will go through, and then that'll bolt. There'll be bolts on the other side that also do that for the shaft. Good. Okay, so let's go ahead and put this whole assembly into the drive assembly. Before we do that, we're actually going to make a leg assembly. That way we can just import that whole assembly in. So create assembly. Can I add these? No, I can't do it like this. Okay, yeah, that's fine. Figures. Can I spell? No. English is hard. I think we've talked about this. Okay. So now we begin to get everything on its correct mates. There we go. You are going to go to here. And then you will go over right here. You there. And this will allow us to put it in and see how much room we've already taken up of what like we expected to take up, right? Because we expect it to take up a certain amount. I do need to grab the springs, don't I? We expect it to take up a certain amount, but are we taking up too much now is the question. What did I say? 0.14, right? What happened to the springs that I was looking at? It was compression springs, an outer diameter of point. Was it 125 maybe? Let me see here. Outer diameter. Yes, I think it was this one, right? Length at max load, no. Length is 25, length at max load is 14. That was not the one. Where's the one that I was looking at? It was this one, the stainless steel. Okay. Yeah, we'll go ahead and grab you. Thank you. Did we need anything else? I don't think we needed anything else, so just grab you, head back to home, and go ahead and import. Where's my spring? Import. There it is. Okay. All right. And then that'll import. Good, good, good. Stick that inside of imports. Very nice. And now we can head back to Drive and finish putting all this assembled it all together. Let's move that out of the way first. And that way we can start assembling all of this. That goes there. This goes underneath. This one is going to go underneath as well. We need to import the bearings, the ball bearings. We need 1, 2, 4 for each. So 16 total. And we're going to need 2 springs for each. For each side, it's going to be 8 total. It's not a flute, but it's gonna end up being well, hopefully it'll end up being a leg for the why am I saying hopefully? I'm not building this. I keep acting like I'm gonna build. I'm not building this. There's no way. That would be insane. No, this is just to annoy Smev. The whole purpose of this is just to annoy Smev. What am I doing with my life? Okay. This is just so that when Smev asks me how my robot works in the D&D thing, I can just be like, I'm gonna talk about it for 30 minutes. Like, what am I doing? It should be funny, though. I mean, it should be funny. Why not make it? because there's a lot of custom parts in this, and I don't have the money for this many custom parts. The amount of custom parts in this is absolutely insane. Like, the amount of custom parts that there would be. It would be absolute madness for me to try. Like, I would... Perhaps in the future sometime, right? I would not be against coming back, visiting this, and trying to make it. But right now, there's no way I could. I could not make this right now. It would be so expensive to try to make right now. I mean, it will be expensive in the future too, but out of used popsicle sticks. I have not considered that. I'm also not sure how well that would work, just due to the fact that it's like, why are you not? Oh wait, it's trying to place the main connector. Oh, I see. Okay. I mean, I don't know how well it would work as a robot with used popsicle sticks. Like, that is something that is a thought I have not thought. That is a thought I have not given any thought to, okay? I will admit that. I have not thought about making it out of used popsicle sticks. I'll admit that. Let's see here. I need a way to put... it's just tough because this only has that. Does Onshape have simulation stuff? So there are extra apps that you can like get for Onshape that will enable it to do simulations. Most of them cost money, so I do not have any, but you can do that with Onshape, yes. That is very much a thing that you can do, and that some people do as well, because like if you're designing an aircraft or something, that's very helpful to be able to simulate what the different forces that will be interacting with it are. I personally don't have the ability to do that, but there are people that do that, and there are the apps on it for it. Can I offset you maybe? Yeah, that should do what I want. That way I can just move it to where I want. Perfect. I mean, I haven't either. I'm just saying, Onshape can be used to do stuff like that, and so the simulation tools can be used for those types of things. That's going the wrong way. Fit you inside of the box there. That being said, all of this to annoy Smev. Smev is watching, I think. So, surely none of this will bite me later. Surely not. Surely this could not go terribly wrong for me later. During the sessions and stuff. That would be silly. Right, Smev? Let's go ahead and put these... Put a bearing onto each of these. I mean, that's not how they're gonna sit in that, that's for certain. Z offset, got it. Like... There we go, that's more like how it'll sit in it. Good, good, good. Offset of the other one was 0.3, I think. No, not 0.3, 0.03. Not 0.03. What was the other one? Was it 0.05? hold on. What was the other one? Let's check our mates. 0.05. It was 0.05. Okay. So yeah, just make them 0.05 then. That works. No, I didn't have too many. Okay. Never mind. And of course it goes the wrong way now. Okay. That's fine. Whatever. .05. Grab another one. This would be such a pain to put together, even if I had the capability to make these custom parts. It's just so small. I'm probably going into more detail than I even need to, but with like I could probably just like put in some boxes and be like, this box is this and this box is that. I'm going into way more detail than I need to for like the D&D session and stuff. But hey, you know, if Smev pulls it up and it just doesn't load on Smev's computer, that is also funny. That's also funny. At least I find that funny as well. I don't know if Smev would find it funny, but I do find that very hilarious. Let's see here. This will go... Okay, so next up we'll put on the plate, I think. So we grab the inside edge of the plate, and we put it onto... Maybe we don't grab that inside edge. We grab... What do we grab? If we grab this outer edge there, then we should be able to put it onto that edge, I think. Yeah, there we go. And then the same with these plates. Just like so. Yeah. Oh, that's not what we want. We want that there. And now we have to do weird flipping and stuff, don't we? There we go. Okay. Now we'd have to reorient it because of that, but that's fine. It's all good. It'll work out. There we go. Okay. So now we go ahead and we take this, and we'll put this inside of here and lower it down by go negative. A 0.04. Okay. And that's where the bearings go. So if we were to look at this, then wrong way. So if we were to take this, do a section view, grab you, and go down like so, we have to go far enough so we can see the spring. That I'm doing so much more than I need to. Oh, I'm making this so much more complex than I need to. This does not need to be as detailed as I am making this. Considering that I'm not building this. If I was building this, yes, this all matters. But now the question is, do we add in bolts? I've already gone this far. Do we just go ahead and go all the way, add in every bolt? Add in every bolt possible, do the best that we can to make sure that Smev's computer doesn't load it. Do we go that far? That would be funny for all of 5 minutes. It would be very funny for all of like 5 minutes, and then it would not be funny anymore. But that 5 minutes would be very funny 5 minutes. No, I think it'll be funnier to just have Smev staring at all of this stuff. I think that'll be funnier. I think that'll be much funnier than the other what I just said a second ago. Smev, this is a lot of work. You better finish the you better finish the D&D stuff. This is a lot of work I'm putting in for this bit. And this should be the last bearing, which means that we just need to finish putting in the springs. There we go. That's all the bearings in place. That just leaves all the springs to get put in. Since we've put in one, we know how to put them in, at least. That is a positive. Though we are probably gonna have to do a section view to do this. Oh. Because we need to see past it to the end. Like so, there we go. I need my other springs. Hold on a second, I can't do this without the springs. They're all the way over here. Okay, that's fine. We'll do this side's springs first. It's all good. I really hope none of my mentors see what I'm doing. That that would probably not turn out well for me. That would be like if your old teacher went and like saw you doing, like your old English teacher went and like you go and you get a job, right? And you're doing stuff with English, but it's like, that's not how English works. I taught you better than that. I feel like that would be very similar to what I'm doing right now. But hey, it's fine. They don't know about this. And I highly doubt it's anything that they will end up seeing. Oh no. Come back here. There we go. And then we go ahead and turn off this section view. And we need to first bring these springs over so that we can still see them with section view turned on. Good. We go ahead and take section view, remove that one, and bring it over here. There we go. And now we can put in these last couple springs. And the last spring, finally. Very good. We can turn off section view again. And the springs are gone. We just put in less spring, but they are invisible because they are inside of that. You can't see them. Oh my, what am I doing? What am I doing? Oh goodness. Anyway. Now we go ahead and add in the slider, mate. You. You. That is not right. Why is it so far in? That's not in the middle here. Why is it so far in? I mean, I can just set it up with an offset, but I don't understand why it's so far in like that. And then that should mean that we can take this and slide it down. There we go. This slider mate, we can go ahead and put some constraints on it real quick. Minimum of 0, maximum of... If we were to say 7, what does that look like? That is going the opposite direction. Let's delete both of these. We're going to change the make connectors to be up here. And get rid of this offset. Change the make connectors to be up top. Like so. And that one is centered. Good. And so now, if I were to slide this, if I change the inner tube mate connector to be this bottom one, I think then it'll slide down, right? Yeah, there we go. Okay, so that means the minimum needs to be, we made it 18 inches long, so that's how long the minimum needs to be. We'll make it 20 for now, just to check. 18-inch minimum, fine. Slides down a little bit. Good, good, good. Okay. Now it puts that up like a foot up or something. So that would be like 30, right? If we slide it down like this, grab section view real quick. Because we want to put the limit so that the limit is hitting the blocker. We can add 2 more inches. 2.2 technically, but it's fine with just 2 more. And we'll do 32.2, it's fine. We slide this down. There we go, we hit the blocker, that is our limit. There we go. So if we go to drive assembly over here real quick, we can delete, not all of this, we want all this kept, but we can delete all of this. We can insert our leg assembly. And we do a fastened mate from here to here. And then we just insert 3 more leg assemblies. Fasten them. Just like so. And the last one. Okay. And we can also see here that we're going to need to cut out part underneath here. At least a 2x2 square. If we head over to base plate real quick, we can cut that out. So if we go back to our base plate sketch, we make a square from each one of these. like so. We equal the sides. Like so, and then we make this 2 inches. And so now that is the same as the outer diameter. That being said, we're actually going to make it slightly smaller than 2 inches. We're going to make it, let's see, it goes in, you got 0.188. So we're going to do 1.712. So if you were to add 1.188 to that, that would come out. And that should add in that in each corner. The bolt holes now have issues because they're missing a extrusion's right there. What do you mean? Oh. Actually, base plate sketch. We're gonna go ahead and add in some lines across, up and down like this. And that way we can just cut out that entire corner section, because we don't need any of the corner section. And there we go. That should cut out the corner section, kind of. It's still extruding some parts for some reason. We're gonna delete all of that. You, and you can all get extruded. And so if we were to look at drive assembly, there should be a hole there now that this can come out of. Perfect. That's what we're looking for. So that goes up and down out of that hole. All good. Perfect. All right. So now we have 4 legs that are stable. What we do not have is we don't have them hooked up to any wiring or motors or anything for them to actually move on their own yet. Right now they're just stable. Nothing happens. They won't break. They won't wedge themselves out of position, and they go up and down on the base plate. So we need to add in the winch. We need to add in the pulley. We need to add in a motor to drive it. Each one needs to have its own motor so that they can work independently of each other. And then we need to add in at the bottom of the leg the whole wheel assembly structure, which we don't have at all yet. We need to add that in. But once all of that is added in, we will then have a working drive system for the robot, for Lil T. At which point, we can then head on to basically just adding... The other stuff that we have to add is not as difficult as this, because a lot of the other stuff is more mythical, not grounded in reality. This is like the most reality-grounded part that we're doing. So a lot of the other stuff we don't need to worry about as much. But yeah, this is a good start for it. Very happy, very happy. All that being said, it's been 4.5 hours, and I do have some other stuff that I need to get done today. So, thank you all for watching the stream. I hope that you enjoyed watching me watching me go mad, trying to make something to make Smef go mad. Yeah. If y'all did enjoy, make sure to follow, and if you really enjoyed, consider subscribing. I'm gonna go ahead and I'm gonna go and like eat food and stuff, because that's something that I should probably do. Yeah. So in that case, I will see y'all next time.